Hi everybody, and once again welcome to my channel. In this today's lesson, uh, again I'm going to continue with the numericals, and these are the numericals for Ibdp physics, and these are from the unit D2 from the book by author David Homer. Okay, so D2 is related to a topic called electrostatic. Okay, electrostatics, right? Now today we are going to solve these two numericals right in front of you in the screen one by one. So let us get started with the first one. Okay. Now the first one says that two point charges of equal magnitude are separated by an air gap of 5 centimeter. The force between the charges is 0.80 millinewton. Okay. A is determine the magnitude of each charge. B is calculate the force between the charges when these are the two conditions. Okay. So let us get started with the information given in the question. There are two charges. Okay, 2 point charges, and they are of equal magnitude. Okay, so let us take magnitude is not given to you. So let us take the two charges as Q1 and Q2. Okay, and they are separated by a distance r, which is equal to 5 centimeter, right? Okay, we don't know the value of the charges. Okay, but one thing is sure, it is equal, right? And one more thing the question says is the force between them is, so Fe. Fe means electrostatic force, right? Between these two charges is 0.80 millinewton. Okay. With this information, you have to carry on. So A part of the question is determine the magnitude of each charge. Fine. Now before we start the calculation, let me tell you one thing. In such problems, to stick to the SI system, your distances should be always in meter. So this is 5 centimeter. So convert it into meter and it will become 0.05 meter. Okay. And the forces should be in Newton. So it is 0.80 millinewton. So this can be written as 0.80 into 10 raised to minus 3 Newton. Okay. So you have to stick to these norms of taking the distances in meter, forces in Newton, and if there is any mass involved, you have to take that in kg. Okay. So right away I have made the conversion so that now we can use these values in the formula. Now the A part of the question is to find out the value of the charges. Okay. So let us start with this formula. Fe, that is the electrostatic force, is equal to K times Q1, Q2, this is the magnitude of the two charges, divided by R square. This is the formula, right? Now K, because this is these charges are kept separated in a air gap. Okay, so your K will be equal to 9 into 10 raised to 9. Okay, because the medium is air. Okay, and because Q1 and Q2 are both equal, so both can be taken as Q. Okay, so this formula can be written as K Q square upon R square. Okay, because Q1 is equal to Q2 is equal to Q. Fine. And the force is given to you as this. Now putting the values of this putting these values, plugging in the values, we get for Fe we'll put 0.80 times 10 raised to minus 3 equals to K value can be put as 9 into 10 raised to 9 into Q square. This is what we want to find out Q, and R square will be 0.05 the whole square. Okay, fine. This will give you, on rearranging, q square will be equal to, you can make q square as the subject of this formula. So q square will be equal to 0.05 squared times 0.80 into 10 raised to minus 3 whole thing divided by 9 into 10 raised to 9. Okay. So this can be again written as 0.05 whole square times 0.80 times 10 raised to minus 3, and this 10 raised to 9 will go up and it will become minus 9. Okay, this thing divided by 9. Okay, now on doing the calculation you will get this value as now only this part if you do, okay, you should get 2.22 times 10 raised to minus 3 and minus 9 is minus 12. Okay, this is 1 second. Let me do this calculation. This is not only minus 1 second. Yeah, 10 raised to minus 12, and here let me do the calculation. It's 0.05 squared multiplied by 0.80 equal to divided by 9. This I am getting as 2.22 only this part if you do, you get the answer as 2.222 times 10 raised to minus 4, and you have this 10 raised to minus 3 minus 9, that is 10 raised to minus 12. Got it? So this works out to 2.22 times 10 raised to minus 16. Okay, which again works out to 2.22 divided by 10 raised to 16. Okay, and if you want to find out q, it should be square root of 2.22 upon 10 raised to 16, right? And if you go and find out this, the answer will be q equal to 1.489 times 10 raised to minus 8, right? And this value can be rounded up to 1.5 into 10 raised to minus 8. Now this value that you get will be in coulombs. Okay, 1.5 into 10 raised to minus 8 coulombs. Now a little conversion, if you make this 15 by multiplying by 10, then you have to divide by 10 also, so it will be 10 raised to minus 9. Okay, so 15 into 10 raised to minus 9 coulomb, and this 10 raised to minus 9 can be replaced by nano, so 15 nano coulomb can be the answer. Okay, so each charge is of the value 15 nano coulombs, or you can say 1.5 into 10 raised to minus 8 coulombs. Okay, both the answers are correct, right? So that was the A part of the question. Now let us see what the B part has to say. Now B part says that calculate the force between the charges when their separation increases by 10 centimeter, 1, and 2, the space between the charge is filled with a material of permittivity 1.8 into 10 raised to minus 11 coulomb square per Newton meter square. Okay, so let us proceed with the B part. Okay, so what should I do? B I will do here. Okay, B part. Now B sub question 1, let us start. Now what the question says, you have to find the separation, you have to find the force between the charges when the separation increases to 10 centimeter. Okay, so now you have to find out the force, electrostatic force, okay, when the separation, that is R, is 10 centimeter. 10 centimeters means in meter it will be 0.10 meter. Okay, so this is the new situation. So again, using the same formula, Fe equal to K times Q1 Q2 upon R square. The same formula. You can write this as K is 9 into 10 raised to 9 because the medium is air, and Q1 and Q2 because we have just found out the value. Okay, it was 1.5 into 10 raised to minus 8, right? So let us take that value, 1.5 into 10 raised to minus 8. Because I told you we have to take the value of charges in coulombs, the distance in meter, and the force in Newton. Okay, so here I cannot take 15 nanocoulomb. I am taking 1.5 into 10 raised to minus 8 coulomb. Okay, and because the two charges are same, Q1 and Q2 are both equal, I will do the square of this. Whole thing divided by R square. R is the distance, that is 0.10 square. Okay, so this should be the calculation. Now here Fe will be equal to 9 times this 1.5 square can be written as 2.25, okay, and into 10 raised to 9. Now this whole thing, I'll do this 9 into 10 raised to 9 times, now this 1.5 I'll make it 15 into 10 raised to minus 9, this side, the whole square. Whole thing divided by 0.10 the whole square. That should be equal to 9 into 10 raised to 9 into this 15 square will be 225, and 10 raised to minus 9 the whole square will be 10 raised to minus 18. This can be written as 0.10 the whole square can be written as 1 upon 100 the whole square. Okay, this can be written as 9 into 225 into 10 raised to 9 minus 18 will be minus 9. Whole thing divided by 10 raised to minus 4. Okay, 1 upon 100 square will be 10 raised to minus 4. This should work out to 9 into 225 into 10 raised to minus 9, and this minus 4 will go up and it will become plus 4. This should give you 9 into 225 should give you 202500 times 10 raised to minus 9 plus 4 is minus 5. Okay, and this should be the answer in Newton. So this is the force value. Now let us convert this into scientific notation. So if you want to do that, I will bring the decimal point at this point, 2 point. Okay, if I do that, 1 2 3 4 and 5, so 2.0 times 10 raised to minus 4 Newton. Okay, this should be the answer in newtons. Okay, so that was the answer for the B sub question 1. Okay, so the force will be 2 into 10 raised to minus 4 Newton. Now if you want, you can do one more thing you can do, divide again by 10, so it will become 0.20, right, and here you multiply by 10, so it will be 10 raised to minus 3 Newton. Now this can be written as 0.20. Instead of 10 raised to minus 3, you can write milli. Okay, so even this can be your answer, 0.20 millinewton. So even this is correct, even this is correct. Okay, in newtons this will be the answer, in millinewton this will be the answer. So that was question number B1. Now B2 is the space between the charges is filled with a material of permittivity 1.8 into 10 is to minus 11. So now we have to find the force, but the condition of the permittivity has changed. Okay. So B2, the condition is epsilon is equal to 1.8 times 10 raised to a minus 11. Okay. Am I right? Yeah, 1.8 into 10 is to minus 11. So this is the condition now, and other things are remaining as it is. Okay, so now your Fe will be equal to, now I cannot use the formula for K. Okay, now I am going to use this formula. Instead of K, I am going to use this constant 1 upon 4 pi epsilon, okay, times Q1 Q2 upon R square. This formula I am going to use. So this will give me Fe is equal to 1 upon 4 pi. Now epsilon is 1.8 into 10 raised to minus 11. Right? Into Q1 Q2. Now Q1 and Q2 we will take the same way, same thing, 15 into 10 raised to minus 9, the whole square. Okay, because Q1 and Q2 both are same, divided by R square will be, it is 0.10, right? No, what is the R square? 0.05. So 0.05 square. Okay, now let us do this calculation. So my Fe will be equal to, in this case, 1 upon 4 pi into 1.8. Now this 10 raised to minus 11 I am going to take up. Okay. So this will be 15 square, so 225 into 10 raised to minus 18. This 10 raised to minus 11 will go up and it will become plus 11. Okay. Divided by 0.05, the whole square. Okay. Now this will be equal to 1 upon, or rather 225, 1 into 225 upon 4 pi into 1.8 into 0.05 the square, okay, times 10 raised to a minus 18 and 11 will be minus 7. Okay, this should be the answer in newtons. Okay, now let us work out this. 225 upon 4 pi into 1.8 into 0.05 squared. Now this quantity, okay, from the calculator, if you plug in the values, you will get 3978.87 times 10 raised to minus 7 Newton. Okay. So this is your answer for B2, but let us put it in the scientific notation form. So in that form, it should be, suppose I bring it over here. Okay, the decimal I bring over here. So 3.978. Okay, how many decimal I have shifted? 1, 2 and 3. So into 10 raised to 3 into 10 raised to minus 7 Newton. This works out to 3.978 into 10 raised to minus 3. 3 minus 7 is minus 4 Newton. So my answer is going to be 3.978 into 10 raised to minus 4 Newton. Okay. To round it, it can be written as 4 into 10 raised to minus 4 Newton. Okay. Or from here, you can take one more decimal on this side, 0.39. Okay. And into 10 raised to minus 4 you can do. And this can be written as 0.39 into 10 raised to minus 3 Newton, or 0.39, instead of 10 raised to minus 3, I'll write millinewton. So this can be your answer, this can be your answer, right? So there are so many forms in which you can write the answer. So that was B2. Okay. So that question is over. Now let us come to this one. Okay. Now this is the question. Let us solve this question. Solution. Now this question says that there are 2 point charges, okay, of values plus 5.6 into 10 is to minus 7 and minus 1.2 into 10 is to minus 6 coulombs in vacuum, and they are separated by a distance 45 millimeter. Okay, so let me take these two charges, Q1, Q2. These two charges are separated by a distance r equal to 45 millimeter. Q1 value is, suppose let us take the positive one, 5.6 into 10 is to minus 7 coulombs, and Q2 is minus 1.2 into 10 is to minus 6 coulomb. Okay, so this is the information, and of course your K is, because it is vacuum, K will be 9 into 10 is to 9. Now with this as the information, let us try to find out A. Calculate the magnitude of the electrostatic force between the charges. So Fe you have to find out the magnitude, okay? Magnitude. So Fe magnitude will be something that you have to find out, right? So before we go for the solution, let us convert this 45 millimeter into centimeter. So into 10 if I do, this will be, sorry, if I divide by 10, it will be 4.5 centimeter. Okay. So let me write this way. My R is equal to 45 millimeter, which can be written as 4.5 centimeter, which can be written as 0.045 meter. In meters, it will be 0.045, right? Rest of the things are okay. This is coulomb, this is also coulomb. Okay. Now let us use the formula Fe equal to K times Q1, Q2, whole thing divided by R square, which is equal to 9 into 10 is to 9, the K value, into Q1 is plus 5.6 times 10 is to minus 7. Q2 is negative 1.2 times 10 is to minus 6, whole thing divided by 0.045 the whole square, because the distance you have to consider in meters, right? Now let us do the calculation. So Fe will be equal to, first let us take care of the sign. This is plus and this is minus, so you will get a negative. Now this 9, this is the symbol, okay, of the sign. Okay, now 9 into, let me take this 5.6 into, let me take this 1.2 into 10 is to minus 7 and minus 6 will be minus 13. Am I right? Whole thing divided by 0.045 the whole square. This should give you the answer as minus, now 9 into minus 13, right? Okay. So this should give you the answer as, I'll just try this one, okay? Right? So that is 9 times 5.6 times 1.2 equal to, divided by 0.045 the whole square. This gives me the answer as 298.66.666, right? Into 10 raised to a minus 30. Now this is the answer I am getting. Okay. Now what I'll do, I'll try to bring it in scientific notation form. That is the decimal, I'll try to bring it over here. So minus, suppose I want to make it 2.98. Okay. So decimal I have to shift 1, 2, 3 and 4 places. So 10 raised to 4 into 10 raised to minus 30. Okay. And this gives me the answer as minus 2.98 into 10 raised to 1 second, I made some mistake over here. 10 raised to minus 13. Okay. Now this is where I made a mistake. There's this minus 7 and minus 6 is minus 13. I did not consider this 10 raised to 9. So I should do plus 9 also over here. And minus 13 plus 9 is minus 4, right? 9, 10, 11, 12, 13. 9, 10, 11, 12, 13. So minus 4. Okay. I forgot to use this 10 raised to 9. Right. So this is 10 raised to a minus 4. And now it will become 2.98 into 10 raised to minus 4 and 10 raised to 4. This will add up to 10 raised to 0. And 10 raised to 0 is nothing but 1. So minus 2.98 Newton. This is the force between the two. And if you round it, you can write it as minus 3 Newton. Okay. So you can see that the electrostatic force is negative. Now negative force doesn't mean anything else, but it means that it is a force of attraction. Okay. Now because these charges are oppositely charged, obviously there is going to be an attraction between the two charges. Okay. And this attraction force is shown by the negative sign. Okay. If it was repulsion, you would have got a positive sign. Is that okay? So A part of the question is done. B part of the question is what? Let us see. Calculate the distance between the charges at which the force is 1 Newton. So now he has given you that the force is just 1 Newton. Okay. Now if the force is 1 Newton, you have to find the corresponding distance between the charges. That is what should be a R. Right. Other all parameters are remaining the same. So again here the formula will be Fe is equal to K times Q1 Q2 whole thing divided by R square. But this time your Fe is given to you as 1. Okay, 1 Newton. So 1 will be equal to K I can take as 9 into 10 raised to 9. Q1 I can take as 5.6 into 10 raised to minus, what was it? 5.6 into 10 raised to minus 7 coulomb. Q2 I can take as minus 1.2 into 10 raised to minus 6 coulombs. Whole thing divided by R square. Now R is something that we have to find out, right? If I bring R square over here, the formula becomes R square is equal to the whole thing. You have to arrange it. Okay, so first let us take care of the charges. I mean the sign. So this is negative. So you will get a negative over here. Okay, that you should get. And your remaining things is 9 I am going to write here, 5.6 into 1.2. Okay, times now 10 powers I'll take 10 raised to 9 minus 6 minus 4 is minus 13. Right, 9 minus 13. That's it. This will be equal to, so R square will be equal to, now 9 into 5.6 into 1.2 works out to 60.5. So I get a negative sign, 60.48 times 10 raised to 9 minus 13 is minus 4. Okay. Now don't think that r square you are getting negative, so there is something wrong. No, this negative sign is only because of the charge. Okay, that is, the charge was negative. It is telling you the type of the magnitude is remaining 60.48 only. So r square, if you ignore this sign, but I am keeping this sign, okay, and if you just ignore it, it will be 60.48 divided by 10 raised to 4, isn't it? This will give you r equal to square root of 60.48 upon 10 raised to 4. And this answer you should get 0.0777 recurring in meters. Okay. To put it in a better way, it will be 7.77 centimeter, right? And still, if you want to express it in millimeters, then it will be 77.7 millimeter. And if you want to round it, it will be 78 millimeter. So this is your final answer for your. Is that okay? So the distance or the separation between the charges should be 78 millimeter in case you want the force between them to be 1 Newton. So these were the two questions that I wanted to do in this today's session, which I have completed. These were based on electrostatic forces, and that's all for today. See you in the next video with a few more numericals. Okay, bye, take care all of you.